4 in the book, so 4.1. Polynomial functions and modeling. You'll identify the parts of a polynomial and use the leading term test to determine in behavior. So parts of a polynomial, this should be a refresher from Algebra 1-2. Your constant is the term that sits without a variable. There it is. So there's your constant. Leading coefficient is the number in front of the term with the greatest power. So this is the one here in blue, leading coefficient. Leading term is the term with the greatest power. 3 is the greatest power of all of these. This is power 3, power 2, power 1, and this has a power 0. If we put this in descending order, it would be 7x cubed minus 2x squared plus 3x minus 3. And then you can see, yep, there is the leading term. If it's in descending order, it's very quick and easy to find. So there's your leading term. The degree of the polynomial is determined by the greatest power found in any term. It is not the adding of the different terms. It is the largest power of all of them. So your leading coefficient, your leading term, your degree of the polynomial or power of the polynomial, all are right here. There's a leading term, leading coefficient, and the degree or power. Those words can be used simultaneously. Okay, in this chapter, you're going to be asked to classify things. So a constant is no variable attached. That's going to be like y equals 3. Anything without a variable. Linear is anything with the power of 1. So y equals, say, x plus 3. Quadratic is going to have a degree 2. So y equals x squared plus x plus 3. Now, not necessarily do these terms have to come behind it. I'm just showing an example. Cubic, so y equals x cubed plus x squared plus x plus 3. And your quartic, power of 4, y equals x to the 4th plus x cubed plus x squared plus x plus 3. Now these are all just simple examples, but one of the things I do want to point out, constant, this is a degree of 0. And notice there's one term. Degree of 1 can have as many as 2 terms. Degree of 2 can have as many as 3 terms, and so on and so forth. So if I gave you something of degree 10, it could have as many as 11 terms. It can't have any more, but it can have less. That's something to kind of watch out for as we move through the chapter. Okay, so in this particular one, determine the leading term, the leading coefficient, and the degree of the polynomial, then classify your polynomial. This is lovingly in descending order. So your leading term is 2.4x cubed. Your leading coefficient is the 2.4. The degree is 3, and this classifies it as a polynomial, a cubic. And there you go. Okay, the leading term test. We're going to go over this in class, but I'm just going to identify a couple of things. If we have an even degree, either both sides are going up or both sides are going down. If you have an odd degree, one side's going up, one side's going down. We're going to talk about this more so in class the day after I'm assigning it. Okay, so use the leading term test to identify the endpoints of the following function. So again, look at your leading term. It's all about the leading term. The degree is 3, which means you have one up, one down. And since it's positive, the right side is up and the left side is down. Anyways, the x's are positive, the y's are positive, x's are negative, y's are negative. So it's going in that direction. You don't have to do anything more than that except for show what's happening at the endpoints. And this one, leading term, degree is 6. So that means both sides are up or both sides are down. And remember from last unit, a negative in front is going to flip it over the x-axis, and so it's going to make all of these x values negative. So both ends are going down. Don't have to do anything more than that on this and that. Okay, so leading zeros of factor polynomial functions. Take each part of your factored polynomial and set it equal to 0. The solution for each of these will be an x-intercept or 0. They're also called solutions, so be aware of these. To write the ordered pair, we use a solution. There it is, the solution for the x value and 0 for the y value. So finding even and odd multiplicity, you have something like x minus c to the k power. If k is odd, so let's x minus 1 to the 3rd power, then the graph crosses the x-axis at c0. So it would cross it at 1, 0. And since this has got a power of 3 on it, it has a multiplicity of 3. And that's how you would write it. The fact that this value happens 3 times. And you won't see it on a graph because it's happening 3 times. It draws itself once. If k is even, so let's do x minus 1 squared, then the graph is tangent to the x-axis at c0. So this would be 1, 0, and it would be a multiplicity of 2. Now on the graph, this guy here, the graph would do this bit. On this one, your graph would come down, touch the x-axis, and then go back up. Didn't do a very good job of hitting it, but I did. That's what it means by being tangent. Crosses, I know you guys are going, oh, that's obvious. Tangent means it touches it and it goes back. So it's kind of like bouncing a ball on the floor. It hits the floor and bounces back up. It doesn't go through the floor. Okay, so find the zeros of the polynomial function and state the multiplicity of each. So this one here, negative 5, 0, with a multiplicity of 3. 4, 0, with a multiplicity of 1. You don't really have to write the 1. And negative 1, 0, with a multiplicity of 2. Now, if you're going, wait, how am I getting these values? It's simple. You take x plus 5, set it equal to 0, so x would equal negative 5. X minus 4 equals 0, so x equals positive 4, and so on and so forth. So in this one, let's go ahead and identify what happens. This one crosses. This one crosses. And this one is tangent. When you start graphing, which I believe is in the next section, this will make sense in being able to graph something fairly easy without a calculator. Okay, so let's look at this one. This time I have x squared minus 4. This thing is squared, so that's our multiplicity, equals 0. So x squared equals 4. Square root both sides. And you get x equals plus or minus 2. So our zeros here are 2, 0, with a multiplicity of 2, and negative 2, 0, with a multiplicity of 2. Because remember, this guy happened twice. I can write it out twice, but why? I'm going to get the same answers. But this is telling me it's happening twice. So the answer I got here is going to happen twice. And so both of these are going to be tangent to the y-axis. Okay, next one. This time they're actually having you guys factor. So this is one of those things we'll have to go through. I might do a mini lesson on factoring or just kind of work with some of you. Some of you guys are going to go, oh yeah, I can factor, not a big deal. So x to the fourth, x squared, don't let that one fool you. It just means that anytime this value is half of this value, you can do it the same. You just have to keep in mind that when you do your parentheses, it's going to be x squared in the front, not x. So do the wagon wheel, if that's what you guys call it. X marks the spot. I need factors of 9 that are going to add up to -10. Since this is positive and this is negative, both signs are going to be negative. And the only factors of 9 that are going to get me to 10 are 9 and 1. So this is going to be -9, -1. Now, if you factored it all out, if you did the wagon wheel idea, then you're just going through here and then multiplying by the number in front. -1, -1, which gives you 9, and +1. But again, you have to remember that it's x squared that these are equal to, not x. So you can see using the wagon wheel, getting to this, or just using this. So x equals ±3, and x equals ±1. So our zeros, or our solutions, whatever they want to call them, 3, 0, multiplicity of 1, -3, 0, multiplicity of 1, 1, 0, multiplicity of 1, and -1, 0, multiplicity of 1. So all of these will cross the x-axis. Okay, this was a little different. You get 4 terms going on here. This is factor by grouping. I'm going to throw that. I did say that a lot. Factor by grouping. Okay, so there's 2 ways you can approach it. You can just simply break it in half. It's all about the GCF. GCF between these two is x squared. And you're left with 3x plus 1. On this side, you need 3x plus 1 as well inside the parentheses. So what did I factor out? A -16. Verify it. 16 times 3 is 48. So I have now 3x plus 1 and x squared minus 16. So 3x plus 1 equals 0, x squared minus 16 equals 0. Subtract 1, you get 3x equals -1. Divide by 3, you get x equals -1/3. So this gives us a factor of -1/3, 0. Multiplicity, 1. And then this one, add 16 to both sides, you get x squared plus 16. I'm sorry. Working ahead of myself. You get x squared equals 16. Add 16, add 16. Square root both sides. And you get x equals plus or minus 4, which gives you values here of 4, 0, and -4, 0. All of these three cross the x-axis. Now, as I promised, there is another way of doing this. Some people like it one way, some like it another way, but this is what I call the box method. And you need the number of squares inside this box as you have terms. I have 4, so I need 2 by 2. And this one has to be in the front, this one has to be at the very end. So the very first square gets the 3x cubed, and the very, very last square gets the -16. Honestly, it does not matter the order in which you put these two. You will get the same answer in the end. And again, it's all about the GCF. Common factor here is x squared. Common factor here, since they're both negative, I'm going to take the negative off. So both are negative, so I get a negative 16. This way, the common factor is going to be 3x. And the common factor here is 1. And you can see I got the same thing as here. 3x plus 1, there it is. And x squared minus 16, there it is. So either or, it doesn't matter. Like I said, you'll get the same answer either way you do it. It doesn't matter where you put things. Okay. Now, the next two are asking you to use a graphing calculator to find the real zeros of the function. And since I don't have my calculator emulator on this computer, what we'll have to do is do this one in class. I'll make a note. However, this is very, very similar to finding the max or min. So if you want to try this one, put this into y1, graph it. So this is just if you have a calculator and you want to try it. Y1 and graph it. And then it's the same as doing a max or min. You do second calc, but instead of the max or min, you want the 0. That gives you the y value of 0. But again, we will do these ones in class to make sure people know what they're doing on a calculator. All right, so this is it on the homework. I did change, well, before the homework, I did change the homework that was originally, so just in case I didn't save the copy when I did it. You're going to be doing 1 through 49 every other odd. Please start the homework, because if you watch this video, it might have taken you 30 minutes to watch the video and write things down. But do start the homework. Some of the homework is fairly easy. That way you're doing the more difficult stuff at school to ask me questions about. All right, and good luck.